Assalamualaikum warahmatullahi wabarakatuh. Today we will do a risk assessment review and explanation. First, background and definitions. First off, this review of the paper Risk Assessment and Risk Management, Review of Recent Advances on Their Foundation by Terje Aven. This paper explains how to conduct risk assessment in risk management. So to get right to it, the concept of risk itself has been studied for a long time, as far back as 2400 years ago when the Athenians considered risk before making decisions. However, risk assessment and risk management itself has been relatively young, only about 30 or 40 years old. The risk field itself has two main tasks. First is conducting assessments to study and manage risk within a specified field. So this is the application of the theory. Second is conducting research on generic risk. This refers to research that contributes to concepts and frameworks for managing risk in general, without focusing on specific field. So this is contributing to a new theory of or framework. So the objective of this paper is to review recent advances in the field of risk with a focus on generic risk ideas and concepts. The topics to be discussed include risk science, the concept of risk, uncertainty in risk assessment, and risk management strategies. First, we need to talk about risk itself. What is risk? The paper provides several definitions. First, it mentions that it is a possibility of an unfortunate occurrence. Second, it's the potential for realization of unwanted negative consequence of an event. C, exposure to a proposition which one is uncertain. The consequences of the activity and associated uncertainties. Uncertainty about and severity of the consequences of an activity with respect to something that humans value. So we could see a keyword or a pattern here. So it's all about uncertainty on an objective. That's really all about it. Now, are all risks bad? According to ISO, it is not. Risk can be considered both positive and negative. So let's give an example first. So we have a negative risk. So here we have Joko. Joko is walking on a wet floor. Now what is the risk of Joko walking on the wet floor? Joko could slip down while walking. Now this is called negative risk because we don't want to slip while walking. Then there is a positive risk, or it's called an opportunity by ISO. So first we have Bowo. Bowo here wants to open a lemonade stand in his university. Now, Bowo could pocket a lot of money by doing so. Now, this is a positive risk or an opportunity because Bowo's business could still either in profit or it fails. Now, so how do we calculate risk to have an idea how catastrophic the risk is to ourselves? So the paper provides several ways to do it. The first is we simply multiply the probability to severity. So here we have P times S, where P is probability and S is the severity of the consequences. So we could hypothetically speak that Joko's probability to slip on the wet floor is 5. So it's 5 times severity. Now Joko's impact on slip is minor, so it's 3. Now it's 5 times 3. The result is 15. So the risk is 15. Now the problem with this formula is that it's too simple. It's just a multiplication. What happens if Joko is an old man? The impact or severity could be increased significantly. What happens if Joko is a blind man who can't see the floor? The probability could be increased significantly too. Now, this formula often overlooks this kind of details. To answer this, the paper has several alternatives. So the first one is the scenario one. It is represented by a triplet, so S, P, and C. So S is a scenario, P is a probability, C is consequences. So here we have a scenario where Joko is a regular man. Now it's the same as the last one, so probability is 5. Now it's 5 times consequences, the impact is 3. Now 5 times 3, the result is 15. However, there is another scenario. What happens if Joko is an old man? So the probability is the same, so 5. Now it's 5 times consequences. The impact is different because it's an old man, so the result could be catastrophic. So we could say it's 6. Now it's 5 times 6. The result is 30. Now what happens if it's a blind man? The probability to slip is 7 because we could say that he could not see the wet floor sign, so the probability could be increased. Now it's 7 times the consequences. The impact still the same as the regular man, so it's 3. Now it's 7 times 3, so the result is 21. What's the difference between the first formula and the second formula? First, we can construct the table right here. We could see different scenarios and the impact and the score. So we are not dumbing down a single scenario to a single number. We will consider multiple scenarios and their possible risks. Now there is another formula. It's called the knowledge one. It is C, Q, and K. It's also a triplet. So C stands for consequences, Q is the uncertainties. Most commonly it is a probability, and last one is K, stands for knowledge. So let's say Joko's probability to slip is 5. Now it's C and 5. The Joko's impact on slip is 3, so it's 3 and then 5. Now here we added a new variable called knowledge. Now what is knowledge? Knowledge is basically what we know of about this risk. Either we say we have a knowledge before about how this risk could play out, or we just hypothetically guess based on our assumptions. We could say that we have a weak knowledge of Joko sleeping on the floor because we don't have any statistic about that. So we could say that our knowledge is weak. So the results will be 3 to 5 to weak. Now what's the difference? So the risk is the same, but the confidence about the risk is not. Because the model in itself is asking how reliable the assessment is, and is it based on real statistic or is it based on guesses. Alright, now you might be wondering where possibilities and uncertainty numbers came from. And you are right. The paper highlights one of the significant challenges to risk is misrepresenting the uncertainty and probability of the risk. The paper emphasizes two types of uncertainty. First is aleatory uncertainty. This basically means randomness. This is a natural variation that we cannot eliminate. For example, weather changes. In this case, it's okay to use probabilities because uncertainty itself is part of the system. The second one is epistemic uncertainty. Now, this uncertainty comes from lack of knowledge. Many risk assessments still assign a probability even when the knowledge behind them is weak. For example, in the previous scenario, do you think I assign probability of 5 from a statistic? No, it's just based on assumptions and my subjective assessment. So how do we deal with this? The paper suggests that we add another variable called strength of knowledge, or SOK for short. Now, behind this probability is to highlight to decision makers that how confident are we about the probability. Or we could use an alternative that is a qualitative probability. So we could say it's a weak probability or it's strong probability. So there is no numeric. Now it's okay to be not precise because decision maker could understand how confident we are on this probability rather than based on assumptions because for precision. Now let's move on risk management strategies. There are three major strategies in risk management. First is risk-informed strategy. This strategy is the most technical one, where we need to do risk analysis, and from those analysis, we decide what to do. We could avoid it, transfer the risk to someone else, or just accept it. The second is precautionary strategy. This strategy is being very careful, especially if the risk has high uncertainty or lack of knowledge, and the consequences of this risk would be fatal. Instead of relying on risk analysis and numbers alone, the strategy prepare for the worst case scenario. For example, a risk of blackout in a printing company. We don't know the exact probability for this risk since it is outside of our control. But if a blackout happens on the company, the result will be fatal. We cannot receive customers, printers and the tools has a probability to be damaged due to being turned off prematurely. So to treat this, we prepare a number of scenarios. So either we prepare to buy an industrial genset so that we have a backup power when the electricity goes down with UPS of course, or we could kickstart a hybrid rooftop solar energy for the company so that we can have a reliable and sustainable backup power. The third one is discursive strategy. This strategy focuses more on communication and stakeholder engagement to build trust and transparency. For example, a public discussion regarding environmental risks. Now, in practice, organizations usually use a combination of all three strategies. Okay, now that we learned about risk management strategy, it's time to learn step-by-step workflow to the risk management process. So first, we establish the context behind the risk itself. So we define the goals for the management and the environment for the risk. The second one, we identify the risk, the possible events that could occur behind the process, and then we analyze the cause of the risk and the consequences. Then we estimate the probabilities and the severity of the risk. And then we evaluate whether it is acceptable and need further treatment. And then the last one is that we treat the risk. In here we act to secure the risk either by accepting it, mitigate it, avoid it, and others. Now, besides these strategies and workflow, we need to talk about advanced ideas behind risk management policy. Now, there are many concepts out there, so let's talk about it briefly. First is precautionary principle. Now, precautionary principle is the idea that if something could cause considerable harm and we are uncertain about it, we should take action even with limited knowledge. Basically, it wants to prevent the risk from becoming a reality by taking immediate action to treat it. Now, you might notice that this principle might not be the best idea, and you might be right because in paper itself, it mentions that this principle is controversial among researchers because of the uncertainty involved. We do not know what counts as high enough uncertainty and how serious the consequences for it to count as precautionary. The second one is resilience. Now, resilience is the ability for the system to keep working or recover quickly when something goes wrong. The key traits for this system is respond to problem quickly, monitor what's happening, anticipate future issues, and learn from past experience. And then we have deep uncertainty. Now, what is this? This concept refers to an extreme situations when we don't know how much we don't know much about the models, probabilities, or even possible outcomes from the risk. For example, we have climate change, pandemic, or other natural hazards. In this situation, risk analysis is not enough because they rely on data that might not even exist. So what do we do? The paper suggests that using a combination of precautionary, robust, resilient, and adaptive approach could help mitigate the consequences. And then we have risk criteria. Now, risk criteria is rules that define what kind of risks are considered acceptable and not acceptable. What's the criteria behind this risk? So, for example, Norway has the petroleum regulations that state that state that the oil operator has a duty to formulate risk acceptance criteria relating to major incidents and to environment. However, there are many critics to this. So first, it ignores the uncertainty because a risk could be the same but has different environment to it. And then second, it might introduce conflict of interest. If the criteria is set by the organization themselves, since the organization could set a higher risk while the society wants a stricter standard. Now, this could be mitigated by making criteria set by the authorities, although this still cannot erase conflict of interest completely. And then the last one, we have integrated perspective. Now, the paper mentions that there is no single approach that is good enough for today's standards. So, the best approach is to just combine approaches that you need based on the organizational needs. So, from traditional risk analysis, precautionary principle, resilience, and many others. Basically, what modern risk management needs is not just about prediction, but building systems that could adapt and improve over time, even under uncertainty. Now let's talk about the future of risk management. Now the field in itself is shifting away from a static risk assessment toward more dynamic and adaptive approaches. The paper highlights the concept of emerging risk, which refers to risks that are not fully understood but may have severe consequences. In these cases, it may not even be possible to clearly define the event, its probability, or its impact. Now, this creates a major challenge, as traditional probabilistic methods may not be sufficient. Instead, a combination of approaches is needed, including precautionary, robust, and resilient strategies. And then the paper also highlights the importance of increasing complexity of systems and interconnection between modern systems. It just means there is more uncertainty because the system often involve interactions that are difficult to model or control. And then we have the key takeaway. So future of risk management is developing better ways to understand, communicate, and adapt to uncertainty. So that's it for the presentation. So thank you for listening and watching.